You think faster than light travel is just an engineering problem. More energy, better engines, stronger materials. You imagine the universe as a racetrack. Speed is just a number, and light, just the current record holder. Break the record, and you win. That's the picture in your head. You see a spaceship chasing a beam of light. Go fast enough, and eventually you catch it. Go faster, and you pass it. Simple, but this picture is wrong. Not slightly wrong, completely wrong. Because light is not moving through space the way you think it is. And speed is not what you think it is. And space is not what you think it is. If you could shatter a mirror in motion, really shatter it at relativistic speeds, you wouldn't just break glass. You would break your intuition. The shattered mirror experiment doesn't fail because of engineering limits. It fails because reality itself refuses the question. And once you see why faster, then light travel doesn't become difficult. It becomes meaningless. You think motion happens inside space, as if space is a stage, and objects are actors crossing it. Faster means covering more stage per second. Slower means covering less. That feels obvious. If one car moves at 50 kilometers per hour and another at 100, you don't question the comparison. The numbers stack neatly. The faster car wins. So when you hear that nothing can go faster than light, you translate it into that same language. Light just happens to move at 199, 7, 192, 4, 158 meters per second, very fast, but still just a speed. And if it's just a speed, then in principle, you should be able to beat it. That's the quiet assumption. You imagine a cosmic racetrack. You accelerate. You keep adding energy. You approach the record holder, and eventually, if your engines are strong enough, you pass it. But this mental image contains something invisible. It assumes there is a universal clock ticking everywhere. It assumes there is a universal ruler stretched across the cosmos. It assumes everyone agrees on what 1 second is, on what 1 meter is. You've never questioned that, because in daily life you don't have to. If you throw a ball inside a moving train, its speed relative to the ground is just the speed of the throw plus the speed of the train. Speeds stack always. This is not physics to you, it's arithmetic. So when you imagine chasing a beam of light, you are still inside that arithmetic. But light is not running on your racetrack, and there is no universal stage beneath it. The race you think you're running does not exist. Now imagine a mirror. Not sitting still, moving. Picture it sliding past you at an enormous speed. Not a car, not a jet, something close to the speed of light. Now aim a laser directly at it. In your intuition, 2 speeds matter. The speed of the mirror and the speed of the light. If the mirror is rushing forward and the light is chasing it, you expect the light to struggle to catch up. If the mirror moves away fast enough, the reflection should weaken, stretch, maybe even fail. That's the arithmetic again. Now shatter the mirror. At the exact instant the light reaches it, the mirror explodes into fragments, each shard flying slightly differently, each moving at nearly the same enormous speed. Here is the question you think has a simple answer. What happens to the reflected light? From your perspective, the mirror was moving. So the reflected beam should inherit that motion. It should gain or lose speed depending on the mirror's direction. But from the mirror's perspective before it shattered, it was at rest. The incoming light approached at light speed. The reflected light must leave at light speed. Both perspectives feel valid, but they cannot both obey ordinary velocity addition. If speeds simply stack, then observers moving relative to each other must disagree about the speed of the reflected beam. One would measure it slower, another faster, yet every experiment ever performed says they won't, no matter how the mirror moves, no matter how fast the source travels, no matter how violently it shatters, the reflected light will leave at the same speed. For everyone, this is not a technical glitch. It is a structural contradiction with your arithmetic intuition. Because if light behaved like thrown objects, the shattered mirror would expose it instantly. Instead, what shatters is your assumption about how motion works. You trust addition. If you walk forward at 5 kilometers per hour inside a train moving at 100, someone standing outside measures you at 105. No debate, no paradox, just arithmetic. This rule is so ordinary you don't even see it as a rule. It feels like part of logic itself. But the shattered mirror refuses to obey it. If the mirror moves at 90% of light speed and the light approaches it, you expect the closing speed to be the sum. You expect the reflection to depend on that sum. Yet experiments insist on something unnatural. No matter how fast the mirror moves, light still approaches and leaves at the same speed. Not approximately the same, exactly the same. So something must give. Either observers in different states of motion disagree about the laws of physics, or addition is not as fundamental as you thought. This is the quiet revolution. Velocity addition, the simple stacking of speeds, is not a law of nature. It is a consequence of deeper assumptions, that time flows the same for everyone, and that lengths do not depend on motion. If those assumptions fail, addition fails with them, and if addition fails, then the idea of just going a little faster than light collapses. Because a little faster only makes sense if speeds sit on a single shared scale. But what if that scale bends? What if the arithmetic itself warps before you ever reach the limit? The mirror did not break physics. It exposed the structure underneath it. You still want light to be special in a familiar way. Maybe it's just extremely fast. Maybe nature picked a very large number and declared it the maximum. That would feel reasonable. But the shattered mirror forces something stranger. The speed of light does not behave like a property of light. It behaves like a property of reality itself. No matter how you move, no matter how fast the mirror slides past, no matter how violently it explodes into fragments, the light approaches at the same speed, it leaves at the same speed, not because photons are stubborn, but because space-time adjusts. This is the part your intuition resists. If two observers move relative to each other, they do not agree on time. They do not agree on length. Their rulers shrink. Their clocks slow quietly, automatically, not as an illusion. As geometry, you imagine time as a river flowing uniformly everywhere, one universal second ticking across the cosmos. But if that were true, the shattered mirror would reveal contradictions instantly. Instead, what changes is the rate at which seconds pass. What changes is the distance between points. To preserve one invariant, the speed of light, space, and time themselves flex. The constant is not how fast light moves through space. The constant is the structure that ties space and time together. Light is not breaking the speed limit. Light is tracing the deepest symmetry of the universe. And once that symmetry exists, the idea of exceeding it becomes something far stranger than going fast. It becomes trying to step outside the geometry that defines motion at all. You still think the barrier is energy, that if you had enough fuel, enough thrust, enough technological audacity, you could simply push through. You've heard the phrase infinite energy. It sounds like a practical obstacle, a very large engineering problem. But that's not what really stops you. As you accelerate, something subtle happens first. Your clocks slow relative to others. Your length along the direction of motion shrinks relative to others. These are not side effects. They are not distortions caused by strain. They are the geometry rearranging itself to protect that invariant speed. And the closer you move toward light speed, the more extreme this rearrangement becomes. From the outside, your clock ticks slower and slower. Your length compresses more and more. But from your own perspective, everything feels normal. Now, imagine continuing, pushing past. The equations do not gently resist. They do not simply demand more fuel. They change character, the factor that keeps time and space consistent. This geometric correction would have to become imaginary. Not metaphorically imaginary, mathematically imaginary. Time would no longer behave like time. Cause would no longer reliably precede effect. If one observer could travel faster than light, another observer, moving differently, could see the same event unfold backward. A message sent after it was received, an effect appearing before its cause. This is not science fiction. It is the unavoidable consequence of breaking that invariant structure. So the universe does not merely demand infinite energy. It refuses the category. Faster than light is not a difficult speed. It is a direction that does not exist within space-time. Return to the mirror, not the glass, the boundary it represents. When light strikes it, something precise happens, an event, a reflection, a clean exchange of cause and effect. Now imagine trying to outrun that reflected beam. If you could move faster than light, you would cross the very boundary that separates can influence from cannot influence. Light does not simply move fast. It defines the edge of what can affect what. Every event in the universe sits inside a structure. Some events can influence you. Some cannot. The dividing surface between them is traced out by light. That surface is not painted onto space. It is space-time. When the mirror shatters, the reflected light still marks that boundary perfectly. Every observer, no matter their motion, agrees on where that edge lies, not on distances, not on durations, but on the causal structure. If you could travel faster than light, you would step outside that structure. You would not just go somewhere sooner. You would arrive before the conditions that allowed you to leave. The mirror's reflection would no longer be a response to the incoming beam. It would become detached from the chain that created it. And then the word reflection would lose meaning. The shattered mirror experiment is not about glass or lasers. It is about the architecture of causality. Light is not a speed limit sign posted by nature. It is the seam that stitches cause to effect. You began with a race. You imagined yourself accelerating across a cosmic track, chasing a beam of light, convinced that with enough power you could overtake it. But there is no track. There is no universal clock keeping score. The shattered mirror did not forbid you from winning. It revealed that the word faster stops meaning what you think it means. Light is not ahead of you in space. It is defining the structure within which ahead can exist. To ask what lies beyond light speed is like asking what is north of the North Pole. The geometry does not extend there. The universe is not denying you greater velocity. It is showing you that motion, time, and causality are woven together in a way that leaves no loose threads. And when you see that clearly, the impossibility of faster, then light travel does not feel like a limitation. It feels like discovering how tightly reality holds itself together.